let's talk a little bit about ion dipole forces. And before we think about how ions and dipoles might interact, let's just remind ourselves what the difference is between ions and dipoles. And I encourage you to pause this video and try to refresh your own memory before we refresh our memories together. All right, now let's first think about ions. Ions are atoms or molecules that have a net charge. So, for example, when chlorine gains an electron and becomes the chloride ion, it's an ion because it now has a net negative charge. Similarly, when sodium loses an electron, it now has a net positive charge. So this is the sodium ion. Now, what's the difference between that and a dipole? Well, generally speaking, when we're talking about dipoles, we're not talking about something that has necessarily a net charge. We're talking about something where the charge is separated on different ends of the molecule. That you have a partially positive end and you have a partial negative end. That there is a molecular dipole moment. And a good example of a molecule that is a dipole or has a dipole moment at a molecular level is water. Water is a very polar molecule. We've talked about this many times. You have your oxygen, which is quite electronegative, covalently bonded to two hydrogens, and those are really polar covalent bonds because the oxygen is so much more electronegative that it hogs the electrons. It's selfish of the electrons, and since the electrons spend more time around the oxygen than around the hydrogen, you have a partial negative charge at this end of the molecule, and you have partial positive charges at the other end of the molecules. And we described this when we talked about hydrogen bonding, where the partial negative end of one water molecule would be attracted to the partial positive end of another water molecule. But as we talked about, hydrogen bonds, which are an intermolecular force, are just a special case of dipole-dipole forces. Things that are able to form hydrogen bonds just have a very strong dipole moment because you have hydrogen bonded to an oxygen, a nitrogen, a fluorine that is quite electronegative. So now that we know the difference between ions and dipoles, how might they interact? Well, you might guess. Coulomb forces are at play. The partial negative end of a dipole would be attracted to a positively charged ion. And I have prearranged these water molecules so that you have the partial negative end is facing towards this sodium positive ion. And so what I'm drawing right over here, these are ion dipole forces. Similarly, if you have a chloride anion or a negative ion, well then the partially positive ends of the dipoles are going to be attracted. And so water might arrange itself in this way, where the partial positive ends, the ends with the hydrogen, are facing the chlorine. And this is one of the reasons why it's so easy to dissolve sodium chloride, to dissolve table salt in water. Those ions are able to separate and be attracted to the water molecules, which are polar, which have molecular dipoles. Now, if I were to ask you what's going to dictate the strength of the ion dipole forces, think about that. Pause this video and what do you think is going to matter? Well, as you can imagine, these are Coulomb forces. So the strength of the charges matter. So you're going to have a stronger ion dipole force if you have stronger charges on the ions. So instead of a sodium with a positive 1 charge, if you had a calcium ion that had a positive 2 charge, then the partially negative ends of the water molecules would be even more strongly attracted. You would have stronger ion dipole forces. Similarly, if you have stronger dipole moments, that will also make the ion dipole forces stronger, or vice versa. If you had a molecule that had a weaker dipole moment, you're not going to have as strong ion dipole forces. Coulomb forces are inversely proportional to the distance between the charges. So you're also going to have stronger ion dipole forces the closer that these things get to each other. But to some degree, that's true of a lot of the intermolecular forces we talked about, because on some level, they are all Coulomb forces.